Our MQP team wanted to be ambitious and throw ourselves into our capstone project. Needing funding to fuel our ambition, we knew the Tinkerbox Award was a perfect fit. Winning the award allowed us to expand the scope and depth of our project. The amount of development seemed overwhelming, but the Tinkerbox mentors provided guidance and encouragement that allowed us to take full advantage of our funding and time. Although we are still only in the first semester of our project, we are ecstatic with the progress we have made thus far. Here is our project. The demand for robots is moving from specialized robots in controlled environments to generalized robots in unstructured environments. In a world designed for legged creatures, wheels limit where robots can go. This realization has led several universities and companies racing to produce high-performing quadrupeds. Previous WPI quadrupeds have not had access to the components they need to be successful, either because of their tight budgets or technology available at the time. Deficiencies in powertrains, materials, and sensors prevented projects from achieving a power density and level of control necessary to perform dynamic movements. The core technology that would allow for our increased power and control are advanced modern brushless motor controllers that enable high-powered brushless motors to function like high-powered industrial servos. Only recently have these controllers come down in price. One such controller is the O-Drive, a popular open-source controller among robotics and quadruped communities. This controller is the basis of our quadruped. Tinkerbox mentorship gave us insight and direction, helping us set and achieve goals. At their suggestion, we started with development of a single arm. This allowed for rapid testing of code, mechanical design, sensors, and microcontrollers. We learned the most from ARM version 1.0. We determined several weaknesses in the layout of components. The motor wires were an afterthought and were extremely susceptible to being tangled and yanked. The geometry of this version would have also limited the quadruped's flexibility. In the process of testing an encoder development board, we discovered numerous issues with the O-Drive software. The second iteration of the ARM sacrificed mechanical simplicity for the sake of wiring and removing the end stops that plagued the first version. We designed and ordered circuit boards for the encoders for the motors, doing the same for the larger electronics to simplify wiring and reduce weight. The motor controller at the core of the project is open source. Due to the number of amateur contributors, the controller has deep-rooted inefficiencies and often behaves unpredictably. Without time to test alternatives, we worked around its deficiencies and pressed on. To fix rigidity and strength issues for the final assembly, we calculated specifications for each of the mechanical components and ordered over 50 machined carbon fiber parts. Attempting to wire each arm to the master controller proved problematic. The microcontroller between the motor controller and master controller had become a bottleneck. Removing it, the O-Drive is now connected directly to the main controller. With our finalized arm, we look forward to assembling and programming our dynamically capable quadruped. Thanks to Tinkerbox, we were able to prototype, test, and iterate quickly. Even if funding hadn't been a concern, without the mentors and community's advice and support, we would not have had the direction and motivation to do all we had. Thank you, Tinkerbox.